Hello everyone and welcome to class. Today we'll be dealing with our SSS1 second week topic, which is logarithms. Now we'll be dealing with logarithm at its basics. Logarithm at its basics. So first off, we would start off with the knowledge of standard form. Now, what is standard form? Standard form is the representation of a number in the form n times 10 raised to the power m, where n is a number between 1 to 10, e.g. 8.2, 4.0, 3.9 and the rest, and m is an integer. Now, we say integer, it could be a positive or a negative whole number. So -4, 3, 4, 2, 9, 5, etc. Okay, for example, you have a number, you have 32,400 and you have to represent this in standard form. You have 32,400. Now, to represent this in standard form, you will have it look like something like this. It's the same number, the number does not change, but you will represent it in this format. So how do you represent this number in this format? For numbers greater than 1, this is what we do. From here, start counting 0. Now you write times 10 raised to the power. From here, start counting from 10 raised to the power 0 till you get to the highest highest place value here. So let's count 0, 1, 2, 3, 4. So times 10 raised to the power 4. Then you take the first digit here. Then you put a decimal point at the back. Then you write the next 2 digits. Are you following me? You take the first digit, put a decimal point after that, and then you write the next 2 digits, which will now give us what? 3.24 times 10 raised to the power 4. 3.24 times 10 raised to the power 4. Now, moving very quickly, you have another number, say 865. This one is also represented as what? Times 10 raised to the power what? 0, 1, 2 times 10 raised to the power 2. Then you take what? The first digit, 8.65. Let's say 900,000,000. How do we get it now? You first write what? Times 10 raised to the power. Are you following me? And so you have 0, 1, 2, 3, 4, 5, 6, 7, 8 times 10 raised to the power what? 8. Then what do you write? The first digit, 9.0. Why do we put just 0.0? Because there's no other digit here that is what? That is greater than 1. So we just write 9.0 times 10 raised to the power what? 8. And this is how we do our standard form for numbers greater than 1. This particular one here. Now, when you have numbers that are less than 1, most especially your decimals. We're talking about your decimals here now. For example, you have 0.1. 0.1 is actually what? 1.0 times 10 raised to the power minus 1. How do we get the power of 10? Very simple. Count how many zeros you get before the first significant figure. Now, how many zeros we get before the first significant figure? Take a look at this. 0.0000300 or 002 perhaps. Look at this now. How do we write it? Now these 2 zeros after here do not really matter. Take note. Do not really matter. What matters is these zeros before the first significant figure, which is 3 here. And so we just write times 10 raised to power what? Minus 1, 2, 3, 4, 5. And then you write 3.0. This is how we represent this. So if you have another number like this, 0.00000009243. What do? You just write times 10 raised to power what? Minus. Then you count how many zeros you have before the first significant figure, which is 9 here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have times 10 raised to power what? Minus 9. Then you now write what? The first digit here. Then you put decimal point after that. You can write maybe 243 or 24. All the same. It's all the same. Now take note, when you are counting for the positive power of 10, when you are counting from here to the highest place value here, you start counting from 0. But here you start counting from what? 1. Do take note. And this is how we represent our standard form. Now what are logarithms? The logarithm of a number is the exponent or power by which its base must be raised to produce that number. Now don't be confused. For example, look at it. Log 1000 with a base of 10 will give us 3. It means 10 must be raised to the power of 3 to give us 1000. Look at the statement again. The exponent by which this base number must be raised to give us this particular number up here. Another example is what? Log 16 with a base of 2 will give us 4. It means 2 has to be raised to the power of 4 to give us what? 16. Now, this definition also tells us the relationship between what? Indices and logarithms. Now, what you're having here can actually be proven. Log has one law that states that what? A log B. Now, this B here is not the base. A log B is actually the same as what? Log B raised to the power of A. If you apply this on both sides, this will give us what? Log 10 raised to power 10. Now, 1000 is 10 raised to power what? 3, right? Which is the same thing as what? 3, 10, 10. Now, another law of indices states that what? With a base of A to the power of A gives us 1. So it means log 2 power 2 will give us 1. Log A power A will give us what? 1. And so log 10 power 10, log to the base 10 and power 10 would actually give us what? 1. Now this 3 is multiplying this, right? So 3 times 1 will give us what? 3. And that's how we can get this answer. The same applies to this side. Log with a base 2. Now 16 is what? Actually 2 to the power of what? 4. Now, if you are finding issues with powers of numbers, there is a part of the video I shared when I was teaching about indices, which is week 1's topic. Do well to watch the video and learn how to create that chart for yourself. It will make your knowledge of indices or your journey with indices and logarithms quite simplified. That chart will make it quite simplified. Okay, very quickly. Now, applying this second law here, we can now take it further and say that what this becomes what? 4 times what? Log base 2 with a power of 2. Now, it means we have 4 times what? Now, applying this second law I just gave here, you would have what? 2 to the power of 2, which is what? 1. So 4 times 1 will give us what? 4. Proving that this is also what? Right. So the logarithm of a number is that power that you will raise that base to be able to meet up with this number. Now, it means if you have, for example, logarithm base 10 power and raised to power 932. It means this will not give you, this one now is 10 raised to power something, but the power will not be a whole number. It will not be a whole number per se. So it will now give you what you call a mixture of a whole number and what? A mixture of a whole number and some decimals. Actually, a mixture of a whole number and decimals. And do take note also, the logarithm of all numbers naturally, especially when there is no base indicated, is 10. If there is no base indicated in a logarithmic question, that base automatically becomes what? 10. Except when the base is clearly stated, like in this scenario where you have a base of what? A base of 2. Our logarithm table is what? Is made with that particular base in mind. So for example, you have log 929. If you have something like this, just take note that what? The base is naturally what? Base 10. Now how do we represent this? This actually is represented when you get the logarithm of this value to give you something like this, 2 points, maybe. I'm giving an example of this particular part now. This will give me decimal values. Now, this particular value and this particular value are different. This is an integer and is known as the what? Characteristic. While this is your what? Your decimal, known as what? Mantissa. This is your mantissa here.